Hello, this is section 7.1. We do the confidence intervals for the mean when sigma is known. So that's the actually is we're gonna do this. And then the next section, so we're gonna talk about the sigma was not known. Okay, so definition as a confidence interval. So confidence interval is the specific numerical value estimate the parameter. So the best point estimate of the population mean and sigma is the sample mean as x bar. The sample mean is used instead of the median or mode because the mean of the sample vary less than the other statistics and when the many samples are selected from the same population. So good estimator have the following properties. So unbiased, the expected value of the mean of the estimate obtained from samples of the given size equal to the parameter being estimated. Consistent. For the consistent estimator, as the sample size increases, the value of the estimator approaches the value of the parameter is estimated. Relatively efficient estimator of all the statistics that can be used to estimate a parameter, and this estimate has the smallest variance. So confidence interval. So statisticians prefer to use the interval estimate because the sample mean are somewhat different from the population mean due to the sampling error. So interval estimate the parameter is an interval or range of the value used to estimate the parameter. So the estimate may not contain the value the parameter being estimated. Okay, next page. So degree of the confidence must be assigned before the interval estimate is made. This is a percentage stating how the confident you want to be that interval does contain the true population mean. So intervals for 95% of the confidence is not as wide as the interval for the 99% confidence. To increase the confidence that the true population mean is in the interval and the interval must be made wider. So definition, confidence interval is gonna be the interval estimate the parameter is a probability that the interval estimate will contain the parameter. Assuming the larger number of samples are selected that the estimation process on the same parameter is repeated. So confidence interval, also the specific interval estimate of the parameter determined by the using data obtained from the sample and by using the specific confidence interval of the estimate. All right, so interval estimate based on the central limit theorem that states that when the sample size is large, approximate the 95% of the sample mean of the sample size samples taken from the population will fold it into the plus minus 1.96, then the error of the population mean, that is mu plus minus 1.9 times sigma over square root of n. And then remember that the z value that separate the middle of 95% from the outer, which is the 5%, 2.5% on the end on the each side of the normal distribution is critical value of the plus minus 1.96. So when a specific sample mean x bar is chosen, and there's a 95 probability that is the intervals of mu plus 1.96 because of 0.025 that we use from the as a z-score, and then we has a z over square root of sigma over square root of n contains the x bar, and there's also 95% probability that is an interval specified by the x bar plus minus 1.96 times sigma over square root of n will be contain mu. Another way to think about this is when the intervals, which is this interval notation of the confidence interval, constructed all the possible sample mean, which is x bar, which is a 95% of the intervals will be contain the population mean of mu. The confidence interval determine the critical value, z, and they used to find the confidence interval. So table E, which is a D table, or technology, or you can use the Excel, or you can use a graphing calculator or a calculator to find the critical values which is a plus minus is alpha over 2 for different confidence intervals. Alpha represents the total area in two tails, which is alpha over 2 represents the area of each tail. And the confidence interval is 1 minus alpha always. So alpha equal to 0.01. Then if you subtract it, and that's the actual percentage you can see it. So formula for the confidence interval will be this one. And then confidence level, so which is instead of defining a z-score, actually this is kind of given to us to use, okay? So 90% is 1.65, 95% is 1.96, 99 is 2.58, which is, you're going to find it the same number from the z-table score too. Okay, so margin of error. So terms of the E, which is same as z sub alpha over 2 times sigma over square root of n. So the margin of the error of the or maximum error of the estimate is likely difference between the point estimate of the parameter of the actual value. All right, a value of the parameter. All right. So let's go to the next page, talking about more stuff. So a lot of definition they introduce here. And over here, and then the margin of the error depends on the following factors. So population standard deviation. The normal distribution can be used to find the confidence interval when the population standard deviation is known. Confidence interval if the larger number of the interval can construct it. The confidence interval represents the expected percentage of the interval that can be contain the parameter. As sample size, a margin of the error decreases, the sample size increases. So assumption for the final confidence interval for the mean when the alpha shouldn't be sigma. Okay, sorry about that. So when the sigma is given, and then samples are the randomly selected. So sample size must be at least 30 or normally distributed, and it's going to be the less than and then 30. The sample size must be the least 30 and then the normally distributed. Oh yeah, when it's less than 30, it has to be the normally distributed. So even with assumptions, keep in mind that there will be always a change of alpha. The confidence interval may not be included the true population mean. Okay, so let's look at the problem that how can we apply. So in the number 1 says the number of the jobs. So sociologists found that in a random sample of the 50 retired men, the average number of the job they had during their lifetimes was 7.2. The population standard deviation is 2.1. So find the best point estimate of the population mean is x bar. Using the x bar, which is 7.2. Okay, so people has 7.2 jobs. And then finding the 95% of the confidence interval for the mean number of the jobs. So we have to talk about alpha, which is this is 95%. So 1 minus 0.95, which is 0.05. So that's alpha. But we need to figure out the z sub alpha over 2. So z is alpha over 2 is 0.05 divided by 2 becomes z sub 0.025. But we only have a number here, 1.96, that we can use from the previous table. The formula for the confidence interval is x bar z sub alpha over 2 of sigma over square root of n, which is less than mu, and then also x bar plus z sub alpha over 2 of sigma over square root of n. So plug it in, x bar is 7.2 minus z sub alpha over 2 is 1.96. And then sigma is going to be also the 2.1. It's a given. So 2.1 and divide by, and then there are 50 retiree, okay. And then mu is x bar 7.2 plus 1.96 times 2.1 over square root of 50. And then when you simplify, you got 0.58, which is less than mu, less than 7.2 plus 5.8. So when you put them together, and 6.62 as a mu of 7.78. Okay, so yeah, that's the answers we got. So 95% of the people in the populations actually have a drop between the 6.62 to up to the 7.78. Now I want to use a 99%. So we use 95% on here. Now I'm using the 99% on this problem. So what makes a difference, okay? So the alpha is now 0.99, which is 0.01. And then z sub alpha over 2, which is alpha is 0.01 over 2, which is a z sub 0.005, which is on the table 99% confidence interval is 2.58 from the previous table, okay? So we plug it into the same place, so x bar is going to be the same, so 7.2, and then minus 2.58 times by sigma 2.1 square root of 50, and then less than mu, and then 7.2 plus 2.58 times 2.1 over square root of 50, okay? So calculate this is going to be 0.77, and mu of 7.2 plus 0.77, so it becomes 6.43, and then mu of 7.97. So as you notice, so 99% has a more wider. 99% is more wider than the 95%. So what can you, which is smaller? So of course, the 95% confidence interval is smaller. Why? Because the margin of error is smaller. Okay, so that's the so it's not that hard to actually find the answers. All right, let's go to the next page. Okay, so we did the similar things, but instead of the nicely we have x bar and the sigma, I need you to find it from here. So the credit union assets. The following data represent the random sample of the asset in millions of dollars of the 30 credit unions in southwestern Pennsylvania. Assume the population standard deviation is 14.405. Find the 90% confidence interval of the mean. Okay, so first of all, you have to find the x bar, which is using the data we have here. Okay, so I want you to add them all together and then divide it, which is I got 11.091. And also the sigma is already given from the problem, which is a 14.405, because it said the population standard deviation is 14.405. Then also alpha is a 90% confidence interval, so 1 minus 0.90, which is 0.10. And then z sub alpha over 2, which is going to be z sub 0.10 divided by 2, z sub 0.05, but 90% confidence is a 1.65. All right, so x bar minus z sub alpha over 2 of sigma over square root of n should be less than mu, and x bar plus z sub alpha over 2 of sigma over square root of n. So x bar is 11.091 minus 1.64 times sigma is 14.405, and over square root of 30 credit union. Then same thing, do you plug it in here too? And then when you simplify, it becomes 11.091, subtract of 4.339, and then 11.091, you get the same value. And then subtract them together, you got this. Add them together, you got 15.430. Now, how do you read this? So which means, therefore, 1 can be 90% confident that population mean of the asset all credit unions is between 6.752 million and 15.430 million based on a sample of 30 credit union. Alright, that's how you answer this. Alright, let's go to the next problem for the sample size. So what will be a good sample size that we can find it for the each of the problem? So sample size. Okay, so the answer to the question how large a sample is necessary to make an accurate estimate is not as simple because it depends on the margin of the error, the population standard deviation, and the confidence level. So solve the E equal to this form, and then when you are actually solving for n, and then n becomes this. Okay, so this is actually you just need to solve for this equation to become this solve for n. So n is going to be this is form. All right, so let's do number 3. Undergraduate GPAs are 3. GPA is 3. How large a sample is necessary to estimate the mean GPA of each undergraduate class at a large university within 0.25 at the 99% confidence interval? Population standard deviation is 1.2. So in order to find the number sample size, should be the G sub alpha over 2 times sigma over E and then square. So alpha is 1 minus 0.99, which is 0.01, which is this alpha over 2, which is 99%. So you get 2.58, right? It's from the table. So that's this alpha over 2, and the sigma is going to be 1.2, and then also the margin of the error is going to be 0.25. So now plug it in. So 0.25 times by the 1.2 over 0.25. And it's going to be approximately 153.363456, okay? But we're not rounding as a normal rounding, okay? When you are rounding it up, we always round up to the next whole number, okay? So next whole number after the 153 is, we have to say 154. So it doesn't matter for the next number 3, okay? We have to say 154. Okay, so that's the case that when sigma is known to find the confidence interval for mean. All right, thank you for listening.